someone asked a question about drug dissipation in the human body, where we have this kind of setup. Suppose that the drug is administered to a person in a single dose, and assume that the drug does not accumulate in the body tissue, but is excreted through urine. Denote the amount of drug in the body at time t by B of t, and in the urine at time t by U of t. If B of 0, the initial amount in the body, is 10 milligrams, and U of 0 is 0 milligrams in the urine, find a system of differential equations for B of t and U of t if it takes 40 minutes for the drug to be at 1/2 of its initial amount in the body. So we'll deal with that in a minute. But here's what I want to say. So you can set up a compartment diagram for this to get the differential equations. It's really kind of the most basic one possible. So here's the amount of drug in the body. Here's the amount of drug in the urine. And we know that B of 0 is 10, U of 0 is 0. And it's going into the urine at a rate proportional to how much is in the body. So you've got some K times the amount of drug in the body, which is B. So I know that dB dt is going to equal negative K times B, right? Because it's going out of the body. And du dt is going to equal positive K times B. And so whatever our K value is, which we'll find on the other side here, we know that our matrix A is going to look like negative K, 0, K, 0. And so our eigenvalues are just going to be negative K and 0 for this particular example. Finding K requires the use of exponential growth decay kind of functions. So we have dB dt equals to negative KB. We know the solution of that differential equation. It's B of t equal to C e to the negative kt. Right, if you took the derivative of this, you would get C e to the negative kt times negative k, which is exactly negative k times b. So the derivative of this, so the derivative of this is this, the derivative of this is exactly this, because it's negative k times itself. Negative k times itself. Solving for k, because that's what we need, we have b of 0 equal to c e to the negative k0, which is equal to 10. So c has got to be 10. Not surprisingly, right? The coefficient here is usually the initial amount you start with. B of 40, right, that's our half-life time, is equal to 10 e to the negative k times 40, and that should equal 5, half of what we started with, which was 10. Solving for k, we get e to the negative 40k equals 1/2. Taking the natural log of both sides, negative 40k equals the natural log of 1/2. Divided by negative 40, we get k equals the natural log of 1/2 of negative 40. And I simplified that. The natural log of 1/2 is the same as the negative natural log of 2, and then the negatives cancel. So you get k equals to the natural log of 2 over 40, which is a positive number. All right, so then, here's our matrix A. It's negative natural log of 2 over 40, and then 0, and the natural log of 2 over 40. And then we're going to find the eigenvalues. Well, they're already there. There's not eigenvalues. Let's do the second one first, just because it seems easier. So for lambda 2 equal to 0, we're trying to solve this. Negative natural log of 2 over 40, 0. Natural log of 2 over 40, 0. Times xy equals 0 times xy. Well, let's see here. X has to be 0, right? We've got, I don't really want to write this out. You've got this times this plus 0 times y. And you've got this times this plus 0 times y. And both of those have to equal 0. So this times x being 0 means x has to be 0. And we know from before that if you find in an eigenvector, right, if one of the things is 0, the other one gets to be 1 automatically. Right, and you can totally see that this works. And if I actually substitute in 0 for x and 1 for y, you can see that, oh yeah, this times 0 plus 0 times 1 equals 0 times 0. And, ooh, actually, is this going to work? Let me see. This times 0 plus 0 times 1 equals 0 times 1. Yeah, it works. Just wasn't sure for a second. And then we'll do lambda 1, which might be a little harder. Let's see. So for lambda 1 equal to negative natural log of 2 over 40. It's probably not going to be that hard. We're going to do, again, the same equation. Negative natural log of 2 over 40, 0. Natural log of 2 over 40, 0. So the natural log times our x, y equals negative natural log 40 times x, y. So we need this times x plus 0 times y to equal the same thing. So we'll say x can be anything, right? You're getting negative natural log of 2 over 40, x equals negative natural log of 2 over 40x, which tells us nothing, right? X could be 1 or a million. But we've got natural log of 2 over 40y, sorry, natural log of 2 over 40x plus 0 equal to negative natural log of 2 over 40 times y. So that tells me that x is equal to negative y, meaning x could be 1 and y would have to be negative 1. So our first eigenvector is 1, negative 1. Okay, so I should probably erase something here. Yeah, I'm going to erase this. So now you just have to take your eigenvectors and your eigenvalues and throw them into the equation that we know is the solution. So right, we know the solution. In this case, instead of x, y, right, it's b of t, u of t, right, because we said it b first and u second, is equal to c1 e to the lambda 1t times v1 plus c2 e to the lambda 2t times v2. And then you're literally just throwing everything in there. So the lambda, right, here's lambda 1, here's v1, here's lambda 2, sorry, v2 is somewhere. Oh, here's v2 right there. And then c1 and c2 will solve for in a minute. So this is going to equal c1 e to the lambda 1 is gross. Actually, it's going to simplify kind of nicely. T times v1, which is the second one we found because I did it out of order, which is 1, negative 1, plus c2 e to the lambda 2 is 0. So if I get 0 times t, I don't really need that, but I guess I'll write it. Times v2, which was this other one, 0, 1. Okay, so simplifying just a tiny bit. So e to the 0 is just 1. So I've got c1, so e to the negative natural log of 2 over 40 actually does simplify kind of nicely. Let me show you before I write this down. So if you've got e to the negative natural log of 2 times t over 40 is how I should write that. Sorry, I kind of fucked it up. So you got negative t over 40 times natural log of 2. And I can write that as e to the natural log of 2 to the negative t over 40. Right, this can come up as the coefficient. And the e to the natural log of some stuff is just the stuff. So this is 2 to the negative t over 40. So I can actually write this whole part here as 2 to the negative t over 40. So I've got c1 times 2 to the negative t over 40 times 1, negative 1 plus c2 times 0, 1. Okay, so here's what I've got. I've got b of t, right, b is the top part. B of t equals c1 times 2 to the thing times 1 plus c2 times 0. So b of t equals c1 times 2 to the negative t over 40. That's it. U of t equals c1 times 2 to the negative t over 40 times negative 1. Plus c2 times 1. So now my initial conditions were that b of 0 was equal to 9 and u of 0 was equal to 0. So that means c1 has to equal 9. Right, so that when you plug in 0 for t, you get 9. And if this is 9, when you plug in 0 here, you get 9 times 1 times negative 1. So this is going to be negative 9. So this has to be positive 9 to account for that, right? So that u of 0 is equal to 0. So it looks like I'm getting b of t equal to 9 times 2 to the negative t over 40. And u of t equals, I'm going to write it as this 9 first, minus 9 times 2 to the negative t over 40. Which isn't surprising because u of t plus b of t should add up to 9. So these parts, if you add these together, should cancel out. So hopefully that helps with this problem a bit. I know these aren't exactly